everyone, welcome back to my channel AWS DevOps Next Level. So in this video, we will do a lab demo on the AWS VPC service. So this is going to be the agenda. We will understand what do you mean by a default VPC and non-default VPC within AWS. And we will see how do you create a non-default VPC and the other associated VPC components like subnets, route tables, internet gateways, NAT gateways, etc. Okay, so now what is a VPC? VPC is a virtual private cloud, which is a logically isolated network in the overall AWS public cloud space. So if at all we need to create a separate network within the cloud with a custom range of IP addresses, with its own subnets, that is a public, private subnets, etc. And we want to create our own internet gateways, NAT gateways, etc. We can go ahead and create a non-default VPC, right? So there are basically two types of VPCs. It is a default VPC, and the other one is a non-default VPC. So default VPC is a network which is provided by AWS by default for each of the regions. It is already available. But if at all you want to create your own network, then we will go ahead and create a non-default VPC. So let me try to show you the default VPC. I will log into the AWS console. So if you see here, this is my AWS console. I am in the North Virginia region. So if I search for VPC here, okay, and if I click VPC, you will see a default VPC that is available. So this is the default network what AWS provides with this particular IPv4 CADR, right? This is the IP range for this VPC. CADR is nothing but a classless internet domain routing. That is a way to represent your network with IP and a subnet mask, right? So like this, for every region, you will have a default VPC. So now if I go into the Ohio region, again, we will have a default VPC here. So this is the default VPC in the Oregon region. And this is coming up with the CADR 172.31.0.0/16, right? So similarly, if I go into the Mumbai region, you will have a default VPC in the Mumbai region. So basically, the VPC is very specific to your particular region. So this is the default VPC in the Mumbai region, right? And this is also is with the same IPCADR 172.31.0.0/16. Now, what are all the various VPC components? So you can see here, under the virtual private cloud, you have many components. So if you see, one is primarily the VPC, and under that you have subnets. So if you want to logically divide your network further, you can create your public subnet, you can create your private subnet, you can allocate the IP addresses for those subnets. So subnets are nothing but individual networks within the VPC. Then you have route tables where we define the rules, how the traffic should flow out and in within the VPC. Then we create internet gateways in order to establish connectivity, typically to the public subnet within the VPC. Similarly, if you want to enable connectivity from the private subnet to the outside world, and that too by using IPv6. So typically this egress only internet gateways is used for IPv6 addresses. So today we know that organizations have started using the IPv6 also. So if at all you want to enable the traffic flow from your private network, the private subnet, to the outside world, you go ahead and touch a egress only internet gateway. Right, so these are all typically the various components, VPC components. Then we have VPC endpoints. There is a NAT gateways and peering connections. So I already have made a video on the pairing connection. If at all you have not watched it, you can just watch that video within my channel. So basically, these are all the various VPC components. You have subnets, you have route tables, you have the internet gateways, egress-only internet gateways, then VPC endpoints, NAT gateways, and pairing connections, right? So based on the requirement, based on the use case, we will attach any of these components to the VPC. Okay, so now you are clear with the default VPC and the non-default VPC, right? So default VPC is the VPC that is already available per region. The non-default VPC is what that we will create with our own set of IP range. Now let me go back to the North Virginia region. Now let us jump into the lab. So this is what I'm going to do as part of the VPC Lab Demo. First is I'm going to create a non-default VPC, that is my custom VPC. So we can do it in any region. I'm going to do it in the North Virginia region. Already we have a VPC, default VPC here, but now here I'm going to create a non-default VPC. So let me click create VPC and I will give it a name, I test VPC. And this is, this is a VPC that I'll create only with the IPv4 CADR block. Although AWS supports IPv6, that is something we will take it up separately. Now this is the CADR that I'm going to use for the VPC. So I will quickly put a diagram on the VPC that we are going to create. So this is going to be our setup, wherein I will be creating a VPC with this particular CADR, that is 10.0.0.0/26. That is going to be my VPC CADR. Then within this VPC, I'm going to create two subnets, right? So I'm going to create one public subnet. Then I'm going to create a private subnet. So for the public subnet, this is the CADR I will use. That is 10.0.0.0/27. And for the private subnet, I'm going to use this CADR, that is 10.0.0.32/27. Okay, so this is my CADR for the private subnet. And within the public subnet, I'm going to launch one EC2 instance that is typically a web server, because web server is what we will launch within a public subnet. So let me launch a web server here, and I'm going to launch maybe another EC2 instance in a private subnet that will be the application server, right? So I will just say app here. Okay, so generally web servers are launched inside a public subnet, and the application and the database servers are launched inside a private subnet. Okay, so now how do we interpret this CADR? So we have a CADR which is 10.0.0.0/26. So how do you know what is the IP range for this CADR, right? So this is how we determine. First and foremost, we will use 32 as a reference number, because all IP addresses are 32-bit address. If you take IPv4 address, all IPv4 addresses are 32-bit address. Okay, so you will take 32 as the reference number. That is the first step. And second thing is, in this CADR, whatever is specified after this 10.0.0.0, that is nothing but a subnet mask. Okay, so you subtract the mask from 32. So in this case, 32 minus 26 will be how much? It is 6, right? So whatever number you get after subtracting the mask from 32, we are going to raise this number in the power of 2. For example, 2 to the power of 6. What is 2 to the power of 6? It is 64. So which means this VPC is going to contain 64 IP addresses. Okay. So this VPC is going to contain 64 IP addresses. And what is that IP range for this VPC? So that IP range is nothing but 10.0.0.0 to 10.0.0.63. This is going to cover all those 64 IP addresses, right? So it is going to start with 10.0.0.0 and it is going to end at 10.0.0.63, 0 to 63, 64 IP addresses. Okay. So now let us go ahead and create this VPC first, and then I will also explain how do we get the IPs, IP range for the public and the private subnet. Okay. So you take 32 as a reference number, subtract that from the slash value, whatever it is. In this case, it is 26. So 32 minus 26 becomes 6. You raise that number to the power of 2. So 2 to the power of 6 will be 64. So this VPC is going to contain 64 IP addresses. The range is starting from 10.0.0.0 to 10.0.0.63. So the whatever instances that you are going to launch within this VPC, it is going to have an internal IP address within this range. Okay. So now let me go ahead and create the VPC, and I'll mention this IPv4 CIDR as 10.0.0.0/26. And let me go ahead and click create VPC. Now, once the VPC is created, currently you see that the DNS host names is disabled, right? So if at all you want AWS to assign a default DNS host name for the instances created within the VPC, you will have to enable this option. So how do you enable it? Now I click actions here and I click edit VPC settings. And here I can just make a check mark on this option, enable DNS host names, and then click save. Okay, so now our VPC is created. Now let us go ahead and create a subnet. So as per our lab instruction also, we have created a non-default VPC, right? Now we will create a public subnet and the private subnet. Okay, now what is the CIDR of the public subnet? It is 10.0.0.0/27. So what is the IP range it is going to have? So public subnet, it's the same calculation. So 32 minus 27 will become 5. And what is 2 to the power of 5? It is 32 IP addresses. Okay. So now this public subnet 32 IP address, it is going to start with 10.0.0.0 to 10.0.0.31. This will be the range of IP addresses within the public subnet. And that is, if I give 10.0.0.0/27, the instances within this subnet is going to have IPs from 10.0.0.0 to 10.0.0.31, right? The first 32 IP addresses. So now let me go ahead and create a public subnet. I click subnet here. And then I click create subnet. So for which VPC I need to create a subnet? My test VPC. This is my non-default VPC, right? And here I'm going to give the name of the subnet. I will mention as public subnet. An availability zone, if at all you want to launch the instance within a particular region, right? So we can go ahead and launch it in maybe, let's say, US North Virginia, US East 1E. Okay. And here, let me give the CIDR block for the subnet. So what is the CIDR for public subnet? It is 10.0.0.0/27, right? That is the 32 IP address. First 32 IPs, you can see here, it is showing you here. It is going to take the first 32 IP address in the overall 64 range. Okay. Now let me go ahead and create a subnet. Now, after creating the public subnet, if I go into the actions, I click edit subnet settings. If at all you want to auto assign the public IP address to the EC2 instances launched within the subnet, you can go ahead and enable this option here now itself, or you can even enable it by launching the instance. Okay, so I have enabled this option, enable auto assign public IPv4 address, and I'm going to click save. Okay, so now we have created a public subnet. Now we will create a private subnet. So what is the CIDR for the private subnet? It is again 10.0.0.32/27. So for the public subnet, it is 10.0.0.0/27. That is from 0 to 31. So for private subnet, the range will start from 32. So 10.0.0.32 to 10.0.0.63. This will be the IP address range for the instances in the private subnet. So if I give the mask, or if I give the CIDR as 10.0.0.32/27, this will be the range of IP addresses. Okay, so now I will click create subnet and I will select my VPC. I will name the subnet as the private subnet. So availability zone, maybe last time I selected 1E, now I will select maybe 1F, right? And what is going to be this IPv4 CIDR? This 10.0.0.32/27. Again, the remaining 32 IP addresses. Now let us go ahead and create the private subnet. Okay, so private subnet, anyway, it is going to have a instance only with a private IP address. It is not going to have any instance public IP. So I'm not going to enable that option. Enable automatic assignment of IPv4 address. Okay, so now we are done with creation of the non-default VPC, and we have created our own public subnet, our own private subnet. Now, what is the next step? Okay, so this step is done. This step is also done. Now we will create route tables for public and private subnets. So basically the definition of the public and the private subnet will depend on the route table that you attach to the subnet. Okay. So whenever you attach a route table with a route to the internet gateway or reaching out to the internet, that subnet becomes your public subnet. Okay. So the subnet to which you attach a route for an internet gateway in order to route the traffic to the internet and also to be reachable from the internet, that subnet is called as a public subnet. So now we will create two route tables. So we will create one route table for the public subnet. I'm going to name it as RT_public. This is the route table for the public subnet. And I'm going to create one more route table, RT_private. This is the route table for the private subnet. Okay. So now RT_public. How do we create a route table? I click route tables here. And then I click create route table. And I will name it as RT_public. So this is a route table for the public subnet. So I select my VPC here. And I just say create route table. Okay. So the moment you create a route table, you need to associate the route table to the particular subnet, right? So I click edit subnet associations and I select public subnet here and click save the associations. Now let me click another route table. I will say route table private. Again, I will select a VPC. I just click create route table. On the same process, I need to click subnet associations, edit subnet associations, and associate this route table to the private subnet. Okay. Fine. Now, what is our next step? So this is done. Step 2 is done. Step 3 is also done. Now we will have to create an internet gateway and attach to the public subnet. Okay, that is very important, because how do you enable communication from the outside world via the internet to the VPC? It is done by using the internet gateway. Okay, so internet gateway typically acts as a router for the instances within a public subnet to contact the internet or to connect to the outside world, or from the outside world to connect to these instances. Basically, this internet gateway is acting as a router. So we have to create an internet gateway and we will have to attach it to the public subnet. I would say not the public subnet here. It is basically attaching it to the VPC. We have to create an internet gateway. Then we have to attach it to the VPC, add a route for the public subnet to reach to the internet. Okay. Now let me go ahead and create an internet gateway. So I click internet gateway here. Whatever you see is a default one, right? So whenever you click subnet, route tables, etc., whatever you see that is already there, it is all the default components. Okay. So now I'm going to create a custom internet gateway. I click create internet gateway and I'm giving a name for it. Test internet gateway. Let me go ahead and create it. Now, once the internet gateway is created, we need to attach it to the VPC, right? So I'm going to click actions, attach to VPC. To which VPC I need to attach? It is my test VPC, right? That is my non-default VPC. And I click attach the internet gateway. Okay. So now, once we attach the internet gateway, we need to edit the route table, especially for the public subnet, to be reachable from the internet. So I will click RT underscore public, and we already have associated the subnet. Now I will click add routes and I click edit routes here, and we will add a route. You see that already we have a default route that is available. That is, if the destination is any private IP within this VPC, it is going to go via the local network. Okay. So you have two options here. One is the destination and the other one is the target. Okay. So how you reach the destination via the target, that is what we specify here. Okay. So if the destination is any private IP within the VPC, it is going to go via the local network. Okay. So now, if the destination is internet, that is 0.0.0.0/0. So how the internet is represented as a CADR? It is 0.0.0.0/0. So if I want to reach out to the internet, then what is my target? I have to go via internet gateway. So let me select internet gateway here. And this is the internet gateway that I created, right? Test IGW. And that is the route I'm defining it here for my public subnet. Okay. If the destination is internet, the target is internet gateway. Select it and click save changes. Now, since we have attached a route table with the route to the internet gateway for the public subnet, that is the reason this subnet is called as a public subnet. A public subnet gets its name from the route table that you have attached it. In this case, we have attached a route table with an entry to an internet gateway. So it becomes a public subnet. Okay. Right. Now we can create one route table for the private subnet also. I will say RT underscore private. So this is my VPC. Create a route table. Now route table for the private route table. Okay, I think we already created it. Sorry, this is a duplicate one. Okay, so we have two route tables that is also created. We have also created an internet gateway and we have attached it to the VPC. Okay, and we have added a route with the internet gateway for the public route table, which is RT underscore public. Now what I will do, I will go ahead and launch a EC2 instance within this VPC. I will go into the instance dashboard. We will quickly launch instances here. So you can see here now we are in the fifth step. Launch EC2 instances in public and private subnet. So let me click instances here. And I will click launch instances. I'll just name it as a web server, right? So this is a web server. I'll select the Linux 2 AMI. Instance type, let it be t2.micro. Maybe I'll create a new key pair with the .ppk format. Okay, now network settings, this will be very important. You need to select the non-default VPC. By default, you can see that it has taken the default VPC, but I want to launch this EC2 instance within my custom VPC, right? So I'm selecting the non-default VPC and where I want to launch this instance in which subnet, it should be within the public subnet, right? So I click public subnet here on the security group. I want to log into this instance via SSH. So I'm just enabling SSH and that too from my source IP address, my system's IP address. Okay, and maybe I will add one more HTTP rule because this is going to be a web server. I will mention HTTP port 80 from anywhere. Now let us go ahead and launch the instance. Now we will try to connect to this instance once it is ready. Okay, now you can see this instance is in the running state, but it is within a VPC, right? So unless and until our route table configurations are correct, we will not be able to connect to this instance. So let me try to do a connectivity check to this instance, or we will directly open PuTTY and we will try to log into this instance. I'll go to SSH, I'll go to auth, and I will select the private key that we just created. And you can see here, it is able to connect to the instance. Okay, great. So I'm already inside the EC2 instance within the public subnet. This being a web server, I'm going to install Apache HTTPD onto this instance. Now you can see here we have logged into the instance which is within a VPC, right? And the communication is happening via the internet gateway. Okay, now I'll just say yum install HTTPD -y. Okay. So I'll start the HTTPD service HTTPD start. Now let us check the status of the HTTP service. You can see that Apache is up and running. Now, if I go to my var www.html, I will define a custom index.html here. I will add a header tag as this is a demo for non-default VPC. Okay, fine. So now if I hit this IP address in the browser, we had to get the response that this is a demo for non-default VPC. Okay. You can see here. Now we are able to connect to the web server within a VPC, and the communication, it's all happening via the internet gateway through our route table configuration. So this is how you connect to the instances within the VPC. Okay. So the logical steps, whatever we followed, it will be very important. So you saw that first we created a VPC with a CIDR, then we created two networks, that is two subnets within the VPC. Then we created separate route tables, one for public subnet and one for private subnet. Then we created an internet gateway in order to communicate via the internet to the public subnet. Then we launched a web server inside a public subnet and the app server inside a private subnet. Then now we verified the connectivity to the EC2 instance, and we were able to install the HTTPD, and we reached the web server as well, right? And we were able to access the content, the static content hosted within the web server. Okay. So I will also make a part 2 video wherein, I will talk about how do you connect to the private instances or the instances within a private subnet from the public subnet, and how do you enable internet connectivity for the private subnet to the outside world. So that I will be covering it in the next video, the part 2 video of the VPC. Okay. I hope this video was helpful. And team, also I wanted to mention that I do conduct training sessions on AWS and DevOps. And if anyone would be interested, you can send an email to the mentioned email ID. And I would be happy to share the details on the course content, the course duration, the course fee, etc. So the training mode is going to be via Zoom, and the class recordings at the end of every session is going to be uploaded onto the Google Drive. So the training is going to span for 5 to 6 weeks, whether you are taking up AWS or DevOps. It is going to, incur at least 5 to 6 weeks of interactive training session, and that it is completely focused on the hands-on lab exercises. Okay. And along with the course, I'm also going to share you some sample resumes if at all you want to try out for any positions within AWS or DevOps, and I can provide some guidance on the interview preparation and the interview questions. Okay, so that's all I had for this video, and I hope this content was helpful. So if at all you have not subscribed to my channel, please subscribe to my channel, and if you feel this content will be helpful for your known circles, please feel free to share this video. So thank you all, and I will meet you all in my next video.